Hi David,
Good
nice
morning.
you are here. You're well known in the IETF. Can you tell us a little bit about your background?
I left for a year hoping I'd get over that.
Okay.
Sorry. Yeah. A little bit about myself.
Yeah.
Sure, I've been doing IETF work for about 20 years. I started out in SNMP land, moved over, worked on security in SNMP, worked over to security in SYSLOG, have worked on NETCONF to varying degrees. Ended up in the transport area as the area director for a couple of years, doing IESG work. And that's about my background.
Okay. And so you're one of the experts on, say, SNMP and management.
Well, sure. If you want to go that way.
Okay. I think you also spent quite some time on the SNMP v3 architecture.
Yes.
Why was this architecture developed? Basically, what questions was it supposed to solve?
The SNMP community in the IETF went through a very difficult time where there was a real deadlock between designing an SNMP version 3 that was a very simple extension of SNMP v1 or developing an SNMP that provided significantly more information for network management application developers. And we ended up in such a bad deadlock that they actually shut down the SNMP community in the IETF for a year.
What exactly happened at that moment? That was when SNMP v2 was under development, and at a certain moment...
SNMP v2 was developed, and that didn't work for various reasons. One of the reasons why I got involved is because the SNMP v2 that was designed first, the SNMP v2 party, wouldn't allow you to do auto-discovery. And auto-discovery was a very important function of SNMP, recognizing when systems were in the network and whether they belonged or not. And we lost that capability because the security was so tight that it wouldn't, if you sent a probe to a system and that system didn't recognize the manager, then it wouldn't even bother responding. So you wouldn't even know it was there and able to talk SNMP. So that didn't work. So a number of network management application companies got involved at that point. HP OpenView, I think IBM Tivoli had some people here. But the network management application side came out and said, wait a minute, this isn't really what we need. When that happened, SNMP v1 up to that point had largely been developed by agent developers who have a very limited view of what is needed in terms of the network management. They're more focused on device management, element management. And we ended up with a very unfriendly environment trying to get through that. So they shut it down for a year.
So the party model that was included in the original SNMP v2 proposals was not accepted. It was also probably too complex. So they decided to split up the group and start a new group, the SNMP v3 group. And you're one of, say, the core people behind the architecture. I sometimes think, if I look at the architecture, that it was a divide and conquer approach. So on SNMP version 2, people had to vote on the entire idea. And so let's now divide it, and then probably it works. Was that indeed one of the ideas behind the architecture?
Yes, yes. It is very important to stress that in the title it's called an architecture, not the architecture for SNMP v3. And it's done very deliberately. It was designed to help get the standards process working again. It wasn't designed for implementers. Implementers are free to implement however they choose. There are abstract service interfaces. In software engineering, frequently called a data flow diagram. Is really what it was designed to do. And it was designed to be a little more object-oriented. One of the missions of SNMPv2 and SNMPv3 was to make SNMP manageable using SNMP. So we had a MIB module for it. Unfortunately, we had one MIB module to manage all the aspects of SNMP, but we recognized that SNMP might be extended various ways, and it became very difficult. We had people working on different aspects of SNMPv3 at the same time, some working on things like the access control mechanisms versus the messaging versus the security, message security. And they would go in and they would manipulate the objects in the MIB. They changed the definition of an object in the MIB, and we found out that when this group changed the object this way, it broke what these people were doing. What these people changed it another way, it would break this group's work over here and really got in people's way. So we designed the architecture to make it separate portions. The messaging versus the security versus the access control versus the applications. And then took the MIB module and broke it out into separate MIB modules. So the access control portion has its own MIB module, and the messaging section has its own MIB module, and so on. And that allowed us to work independently of each other. And using these data flow diagram ASIs between the portions. So the people working on, say, the messaging knew that they can make any change they want, but there was a public interface to their object-oriented development, and they couldn't change that public interface without talking to the other people who shared that interface. That allowed us to move forward. It also allowed for, there were a number of people claiming that they needed a messaging model that was going to do this. There was somebody, I think, that argued they needed to be able to make it work with SNA or something, and there were people who wanted to use it on constrained devices, and they needed to have really small messages and so on. So by breaking the architecture up into pieces and defining the interfaces between them, you could define new message models or new security models or and so on. And that allowed other people who were in the rough in our IETF community, who claimed that they needed something different than what most people needed, were free to go design their own and plug it into the architecture, basically. Now that wouldn't work with an implementation because implementations don't follow this architecture. They're free to do it how they want, so you'd have to go design your code to go fit your architecture, your implementation architecture. But it allowed you to document your proposal in a way that wouldn't interfere with other proposals. And it allowed us to make it much more feasible to do that. Now, interestingly, nobody else has developed a new messaging model. And the security models that became in demand were not consistent with the way our architecture was designed, where the security was built into the messaging. The operators wanted to use TLS and SSH, where the security happens before you get to the messaging. And so we didn't have a transport subsystem, and we didn't have a way of having different Varbinds content packages. So those are the two places where actually the demand has been the greatest for change, is the place where we didn't allocate it in the architecture. But hey, you do what you can.
If I look at the architecture and if I look at the access control subsystem, I see it's part of the SNMP engine. Whereas if you look at the interactions that it has, it is with the application. So I always find it hard to understand why it's not part of the applications. Can you explain why this choice was made?
Sure. Security is a process. It has to be holistic, to use a nice term people like to use. It has to work regardless of which, it has to work consistently, regardless of which security model you're using, which messaging model you're using, which applications you're using. You can't have it apply access control if you're doing a query response command, but not when you're doing notifications. So the access control is done outside of the application so that it's consistent across all the applications.
So is the idea basically that the SNMP engine, so the lower half, is doing the generic stuff and the application, the specifics, and it's not so much where do you see most interaction between which modules? Is that correct?
I'm sorry. I'm going to have to ask you to repeat that, but I want to make a point. Application is a piece of inside the engine that's running its. It's not an application like something that runs on a host. Mm-hmm. It's a portion of the functionality. Mm-hmm. Okay. So I'm sorry. Your question was, it's part of the general engine.
Yeah, if you look at the, say, SNMP, you have, say, the lower part, right, and you have, say, the upper part. And the lower part has, say, the modules for the processing, the security, and also the access control. Whereas I would have expected that the access control is closer to where, say, the MIB objects are.
There's a definite effort in SNMP to separate out the data modeling from the protocol that carries it. Mm-hmm. And the security has to apply regardless of the MIB modules that you're using. Granted, you have access to, you can work your access control in such a way that you can specify a particular MIB or subtree within a MIB module. But ultimately, we felt it was the purpose of the engine, the responsibility of the engine to verify that access to certain objects, regardless of the operation you're going to do on it, is specified in the access control model. And within the access control model, you can specify which operations are allowed per user.
Okay. So. If you look back at, say, the purpose of defining the SNMP architecture, and you said it was to bring standardization working again, and I think it succeeded there. What I found interesting, however, is if you look at the IETF, it's hardly doing architecture standardization. So this is
Absolutely
one of the exceptions. Do you think that the IETF should do more architectures, or do you think this was a specific case? Or
I'm a pretty strong believer in the precept that the IETF does a lousy job at doing architectures. The IETF works bottom up. The ideal way of working is to have, if there's a problem in the wild to be solved, multiple vendors will go solve it. And once they've solved it, then they come together and try to agree on some standardization about how to solve it. Operators who have to work with mixed vendor networks will have a problem they need solved and then need to get each of their vendors to solve it. Then the problem becomes that they have to go figure out how to solve this problem using vendor-specific solutions, and it's better if they can get them to work together in a consistent manner. Architecture tends to be built from the top down, and it tends to be theoretical. And one of the problems in efforts that we have done in the IETF and in other standards organizations, which tend more often to be top down, is that you end up including lots of, here's a little edge case and here's a little edge case, and we need to include that in the architecture. How do we handle that? And the architectures end up being huge. The IETF, and specifically SNMP MIB development, is designed on the precept that you want to have a minimal amount of standardization. You go find the common denominator and you standardize that. One of the interesting properties of that approach is that SNMP MIBs are very good for monitoring rather than for configuring. Because to configure, you need to understand all of the knobs that need to be configured for a particular vendor's implementation. Whereas to monitor, you can get by managing the common subset monitoring. the common subset. So SNMP has become very good at monitoring. It's not very good for configuration as a result.
Would you, with your current knowledge, have done SNMP v3 differently, for example, to better include configuration management functionality?
The whole purpose of SNMP v3 was to provide the security so that SNMP could do configuration. But people don't use it because it's not convenient. It's hard to work with.
Why is it not convenient? Why is it hard to work with?
For people who have ever worked with relatively primitive basic language development, there's the concept of peek and poke. When you find a memory location and you put a value into it or you take a value out of it, sort of assembly language level programming. SNMP and MIBs, with its very limited set of verbs, has sort of a peek-poke mentality to it. You can go set a value into an object, you can read a value out of an object, but that's about all you can do with it. And that's really hard to work with when you're trying to, say, configure a service that has multiple aspects to it. It doesn't handle transactions well. You can make them work. We have, one of the objects you can do is in a MIB is design it so there's a button you can press that causes an action to occur. But that's not the way people think about doing configuration when they operate networks.
SNMP is simply too low level, what you said. It is writing low-level stuff. It's
low-level for configuration, yes.
Yeah, for configuration.
Right. It's not very well, it's not task-oriented, it's data-oriented.
I remember that at a certain moment people said, it's not good for configuration, let's go to COPS PR. But COPS PR disappeared. Why did it disappear?
The IETF had a very significant policy about doing network management, that the one protocol for doing IETF management, I'm sorry, I take that back. The one approach to modeling for network management was the MIB, developed using the SMI. SNMP was one of the protocols that should be able to access the MIB. The other one that they tried to plan for was CMIB, which never really finished. Or if it did, it never got accepted in the internet community. I'm sorry, I forgot your question.
It was basically why COPS PR didn't...
Oh, COPS PR, sorry.
Yeah.
So COPS PR came along and it was developed. So the SNMP community had a very serious problem in that we were shut down for a year. The only thing we were allowed to work on was making SNMP secure. That was really the goal of SNMP v3, and it took us about 3 years, I think, to do it, if I remember correctly. During which time there were other features that we would have liked to have had and couldn't work on. We weren't allowed to work on anything else except securing SNMP. Another area in the IETF decided that they wanted to do configuration using COPS PR for provisioning, which is actually distinct from configuration. There's a difference there. When they came up with their proposal, the SNMP community really objected strongly to, wait a minute, we weren't allowed to work on this, how come they could? And they fought against it. The COPS PR is policy-based management. I think that what COPS PR did for design was actually a fairly good thing. They, however, had a locking capability. One of the things that COPS PR was designed to do was to set a policy, and if anybody changed the configuration information, that it would automatically go in and overwrite those changes. So an operator could not go in and manually change a parameter of something in order to debug a problem or whatever. They had to actually shut off the COPS PR for that functionality so that it wouldn't overwrite them. And SNMP couldn't work at the same time and so on. So It required that it be the sole master when it was operating. And that just wasn't acceptable. Operators said, no way. And they tried to design around it by putting in on-off switches, and you could go in here and shut off certain functionality and so on. But it just really kind of left, I think operators at that time were not ready to accept the idea of a automated, policy-driven management that was going to override what the operators were doing, that operating a network wasn't sufficiently clearly defined yet, and still isn't, for policies to be defined that would be solid enough to not make mistakes and destabilize the network being applied.
We have now a configuration protocol, NETCONF, and IETF is working on that. I think that's working quite well. At the same time, you see the concept of software-defined networking and open flow getting a lot of attention. How do you see the relationship between open flow and NETCONF?
I don't know that I haven't paid a great deal of attention to SDN. There are I've been in the IESG, and in the IESG you've had to pay attention to the major trends and whether they're mature enough to be accepted for a working group. And the purpose of a working group is, of course, to mature standards before defining what a standard is, really getting a clearer understanding of what are the requirements and so on. I've taken the last year off. At the point that I left, SDN was one of many emerging technologies that were hot, but not necessarily well defined. So SDN, clouds, virtualization, a lot of these were being solved in the real world, but weren't ready for standardization yet.
But if you look at the concept of software-defined networking,
Yeah.
and if you look at the idea of network management, is there a fundamental difference?
No, I don't. I think they're
For you, it would be
similar.
similar.
I look at them as being related. I think NetConf is designed to be a configuration protocol to make it closer to the way the CLI works, to be able to understand all the vendors' individual knobs in a way that works well with the standard. I mean, obviously in SNMP we had vendor MIBs as well as the standard MIBs, but NetConf is designed to really take a look at the tweaks that need to happen in order to accommodate specific vendors' equipment. So if you're going to do configuration, I think NetConf appears to have the right answer at this point. And I think that the fact that it's standardized is a benefit above CLI, because the big problem with the CLI and the reason NetConf was developed is that screen scraping, going in and using expect and so on to try to parse through screens of information that are not laid out in particular ways, aren't necessarily well marked, and varied, sometimes significantly, sometimes just minor differences between model releases or firmware releases was a real problem, has been a real problem for operators for a long time. And NetConf helps to solve that. I think that NetConf needs to do a lot of work at building the equivalent of a MIB. There are a lot of SNMP MIB modules available, so there's a significant amount of functionality that can be monitored using SNMP. The amount of functionality that can currently be configured using NetConf is limited by the lack of data models. And I think that's one of the places where they really need to grow. One of the big complaints about SNMP for configuration was that the MIB modules didn't extend to everything on the box. So when operators needed to configure all of the aspects of a box, they had to go to the CLI anyway. So if they had to go to the CLI anyway, why bother using two different protocols? Why not just use their CLI? And the CLI typically came with the device when they bought it, and the MIBs had to be developed, the standard MIBs especially had to be developed after the fact. So by the time the standard MIBs came along, the CLI solution was already in place and working. So it didn't make a lot of sense.
Dave, thanks a lot for the interview.
Sure, happy to do so.
Okay.
Thank you for having me.
Okay, thanks.
Have a great day.